Hello and welcome again. Welcome to the NetScaler live demo, where today we'll be covering enhancing DNS security, NetScaler's role in facilitating encrypted DNS traffic with the TLS protocol. And I think this is the point really where I hand over. But over to you for today's agenda.
Hey everyone, good morning, good evening. I'm Uttam Somani. I'm a product manager at Citrix. Over here we will be covering why DNS over TLS is important, and then what all NetScaler have developed as part of supported modes on DOT, which is Proxy Mode, ADNS Mode, and Mix Mode. We also have enabled the secure caching mode in DOT, which we will be covering through. And then we have the main agenda for today, which is demo of how we will be covering how to configure, then how these DOT counters are visible, then how you can see with the secure monitor, DNS secure monitor, and we also going to show you the packet capturing where you can identify how it is secure and why it is important. So going to the next slide. So why DNS over TLS is important. If you see in today's digital world, where online privacy and security is the most important thing, and it is the need of robust security tools and system have become increasingly obvious. With the importance of DNS traffic, DOT is what it actually is. It's a security protocol that enhances the privacy and at the integrity of DNS. It works on port 853, and where it will help you by encrypting the communication between DNS client and server. So with DOT, you get the benefit of you get saved from the attacks like DNS spoofing, DNS snooping, cache poisoning, and DNS hijacking. At the same time, it also helps protecting from unauthorized access on your DNS. With these things, the benefit which any industry or any enterprise get is they get their online asset get protected. They have an improved operational efficiency because of the seamless protected DNS, which or other part which we will be covering, like why what all modes we have. We'll be going to the next slide. So what actually we do in DOT in proxy mode is, so let's take an example. You have an LBV server and you just have to set your back service type as DOT. Then what NetScaler over here is doing is a TLS handshake with the client and server to establish this secure TLS connection. And subsequently, the same client transmit encrypted DNS queries to NetScaler, which decrypt and applies any configuration DNS or SSL policies on the V server. What actually we do is the re-encrypt the request and forward it to backend. So at both the ends, you have an encrypted, where NetScaler is doing the role of as a resolver, and it is decrypting and encrypting and sending it at both the side with a proper secure channel. So the server responds with an encrypted DNS reply, which NetScaler again decrypt and apply these configuration policies if anything is present, and then re-encrypt the response and send it back to the client. So overall, the whole channel is encrypted over here, which actually give you a benefit of secure, which actually give you a benefit of from all encrypted DNS queries, give you a benefit of heightened privacy, and it at the same time shields your DNS query with your network surveillance, which help you to enhance your privacy, especially on untrusted networks. Vivek, can you go to next? So the next part, which is very important, which help to in seamless transition of your queries, which is DNS secure caching. In DNS secure caching, the major benefit is if you already have a type of vServer and services of type DOT, then NetScaler just caches the record as a secure record. If you don't have it as type DOT, then what it will do, it will send it. NetScaler provide. So NetScaler does not have that secure record in the memory as it is not cached. It won't serve the record from the cache. Instead, NetScaler will contact the source, which is the backend server over here, read the most recent data and share the secure record while updating the cache. And if you don't have any of them type as DOT, it will continue to serve them as unsecured cache. But the major benefit when you have it as type DOT, it convert them from unsecured cache when it is not having in the cache memory, and then it converted it to a secure cache, which is how it's been shown in the diagram. You can easily understand.
If I could interject at this point. What kind of customers are asking for these features? Where would you expect to see this deployed, and what's driving this change to security?
So basically, this is a general industry shift, which whoever is looking for towards more privacy and security. So as you can see, there is a growing awareness of online privacy concerns and potential manipulation of DNS traffic. So these data breaches and cyber attacks are being more common, which are leading businesses and individual to secure. And DOT encrypted DNS queries make it hard for to tamper them. Yeah.
So would you expect to see all businesses starting to adopt this form of DNS request, or is this just particular subsets of customers it's going to be most applicable to?
Majorly, if you see already industry is shifting toward this, and BFSI, if you see in the medical line, if you see due to regulatory requirement as well, some industries are making it mandatory for encrypting the DNS traffic. So either mode you can choose DOT, which is DNS over TLS, or DNS over HTTPS, or DNS over Quick. Just having DNSSEC does not help you over here. You need to have an encryption protocol, which will help you which will help you harden the security and protect it from tampering.
Okay, thank you.
So going forward, Vivek, you can go ahead with the next mode.
Sure. Hi everyone, I'm Vivek. I'm from engineering team. So next mode we support in DAT is ADNS mode. Some of you might be aware of ADNS. Basically, ADNS mode is NetScaler works as a DNS server kind of thing, where the prerequisite is to add DNS records beforehand, like the domain and IP record. So what will happen is, like, the particular DOT, ADNS DOT or DOT supported client, it can directly query to the NetScaler IP, like with that particular dig or any command, DNS command. So what NetScaler will do, whatever the record it has configured, it will serve from the configured record with the response, like any domain, avc.com, it will respond with the IP address. So for that, like, we have added this ADNS underscore DOT type. I will cover again all this thing in the configuration part. And so here, this is the new type, ADNS underscore DOT. So this is like encrypted, like whatever response will go from NetScaler, it will be encrypted. So
if I could just jump in for a second before you go on to the demo. When I configure my NetScaler's in ADNS mode, it's normally because I'm running something like GSLB. So is this supported for GSLB?
Yes. This is also like DOT is also supported for GSLB, because ADNS is used heavily in GSLB. So with ADNS underscore DOT mode, GSLB will be also secure.
Okay, fantastic. So if I had a standard deployment, multiple data centers, I was distributing traffic now, this is something presumably I could just do a firmware upgrade and add on and enhance my security pretty much immediately.
Yes, definitely.
Okay, fantastic. Thank you.
Okay. So let's move on to the demo part. Okay, so basically some of the configs I have captured here. So like Uttam said, we have like front-end LBV server backend services. So there are some examples here. So this is a particular LBV server. So this is basically the command, add LBV server. The type, if you see, it is DOT type, DNS over TLS, and the port is 853, which is the standard port. Similarly, for service also, add service, DOT service is service name, the backend service IP, and again the service type DOT and the port 853. So key thing to note is that LBV server and service, it is like as usual other services, only the difference is the new service type, which is DOT, and the port, which is 853. In case of DNS UDP or DNS TCP, it is 53. For DOT is 853. So
and that's a standard port then?
Yes, it is as per the standard.
Okay.
So the if like when you bind these two, it will be like the combined end-to-end DOT. And one important thing to mention here is, like, we need to bind the certificate to this particular front-end vServer, because to make it up, because it is a SSL type of vServer as well. So what I mean is, when we enable like DOT type service, this is DNS over TLS, so that particular vServer, it supports all the SSL functionalities as well. So that's why when we create a DOT LB vServer, as it is a front-end listening vServer, it has to be bound with the certificate. And this certificate, it is pre-configured certificate like we do for SSL, SSL-based vServers. Similarly, we need to bind this SSL vServer to this certificate to make it up. That is one key thing. And this particular behavior is for ADNS as well. So what I mean is, this is a ADNS DOT service type. If you see add service ADNS DOT, then the IP, then this is the service type ADNS underscore DOT and 853. And here, if you see, we have this particular, so here also we need to bind the certificate. Currently, it is not captured here, but similarly, like we need to do set SSL service ADNS DOT hyphen. So basically for ADNS ADNS based service also, we need to bind this particular certificate to make it up. So that is also there, because it is a front-end service, it is a listening service, we need to bind that as well. Same as the vServer. And we also support Secure Monitor. So I will show you the configuration of that.
Just as you're showing the configuration of the monitor here, these of course are services where the NetScaler is listening for DNS queries coming from the client. Can I also make the NetScaler use this DOT load balancer as its own DNS service?
Sorry, can you come again?
Well, on my NetScaler, I would have
Yes.
I would have configured the NetScaler pointing to a number of DNS servers.
Yes.
So can the NetScaler do its own DNS resolution through DOT now?
Yeah, NetScaler can do. That is currently in progress. Like you are telling about the resolver kind of thing, right? Where it can resolve some of the domains. So that support also we have. That support currently it is in progress. Like a resolver across like DNS TCP resolver and DOT resolver, we are coming up with that. So currently, what ADNS DOT is basically pre-configured records it will serve for the DOT queries. So this particular is a secure monitor. So what monitor is, generally we use monitor to bind to particular service to check the health and to make it up or so. Like we use custom monitor. For DOT based service, we need to bind with a secure monitor. So for secure monitor, we have to make the secure option as yes. So it is basically a DNS TCP type monitor with query domain and the query type address, and with secure flag a yes. To make this, but make a particular DOT based service up, we need to bind DOT based, secure DNS monitor only. So that is one part for custom secure monitor. Otherwise, like default TC monitor will work as well. If we want custom monitor, we need to make the secure option as yes for DOT type of services. So these are the service, these are the configurations point of view, like what we have, like we covered LB vServer and services, backend services of type DOT port and secure monitor, as well as ADNS DOT also. We also support mixed mode where you can bind front-end LB vServer with backend DNS TCP and vice versa as well. Some of the customers might require that when the backend can be unsecure. So that also we support.
Okay, so that would be a front end with DOT and a back end with DNS TCP?
Yes, you're correct.
Okay.
So I will move so there are some issues with the lab devices. So I have recorded previous sessions. I'll move to DNS logging part. So here, if you see, these are some of the configs like we do syslog server configuration. I have added like some of these configs, add audit syslog name and the IP where the syslog will be captured. So this config we need to add, and the logging will be basically you need to do send the traffic and do show audit log messages. So here what will do, you can grep for 53. 53 is for DNS TCP or DNS. 853 we can grep, which is for DOT. So when you grep, we can see the service port and the cipher suite and all the configurations here for the DOT based services, backend services and all. And also like we can, we will also start the traffic once and see whether how it goes. So here, this is a client, DNS client, and we are using dig tool to generate the traffic. So here, this is the IP, 196 is the IP, backend IP, and I am using plus TLS to generate an encrypted DNS query. So this I will use at generating a encrypted DNS query.
And just to clarify, when you've got plus TLS on here,
Yes.
this presumably is the client-side configuration that would be necessary. If you
Yes.
if you're doing this manually, you're not doing anything other than putting plus TLS on a dig command.
Yes, basically what is like, this is a particular Linux, like this is a, you can
Mhm.
say a client application running on a Linux
Mhm.
Linux box, which will create a DNS query and send to this IP address. So this IP address, nothing but the IP of the LBV server.
Mhm.
And this domain is n1.dot.testing.com, and plus TLS is
Okay.
basically, it has the support. This particular application has the support of plus TLS. Based on the client usage and their design of the application, they can use or not use. For our testing, we have used this dig tool, and dig tool supports plus TLS for encrypting the DNS query.
So for a normal client application, as opposed to for a testing tool like dig or drill, what would
Yeah.
you do for a normal client application? Is it an application specific setting that you would turn on to do TLS, or is it something operating system specific? How does that normally function?
So it is application generally when a particular client wants to send a DNS query, like let's say we have this particular our Windows laptop or anything like browser and anything, right? When we try to do a resolution for a particular domain. So based on the configuration, like if the support is there in the client side, it can use the encrypted to send the encrypted DNS query to the particular ISP, wherever this NetScaler is, right, in between. So that is up to client how they
think I
use.
understand. I think what we're saying is that 853 is the default TLS port.
Yes,
This is an industry standard. If the client supports TLS, you merely turn it on. However, you happen to turn it on in that particular application or operating system. And because we follow the standards and they do as well, everything's golden. Is that right?
Yes, correct.
Okay, thank you.
So yeah, so here let's generate the okay. So here you can see the particular IP address, and here we'll come back to the logging again. We'll do a show log. Here, if you see the logging, one more entry log has been added. So this is specific to 853 port. So this is basically the DNS logging, how it would work. So also we will now we will see some of the counterpart, like some of the counters to see how it works. So we'll go to cell mode, and there are few counters like DNS provides, like TOT queries and TOT server responses. So mostly we will focus like on two counters. One is TOT server queries and TOT server. There are some other also counters DNS provides. So, but in our main goal is to have the two counters only. So, which is TOT server queries and TOT server responses. I will cover that 1 second. So here we will generate some traffic to see the counters. It will come. Yes. So basically, 1 minute. So okay. So one more thing, we have to disable the caching to see these counters ineffective, because what I mean is, if we have the caching enabled, we cannot the whatever server response, it will not come from the backend server. It will only serve from the cache, so that those counter will not increase. So we need to disable the cache to see whether the particular DNS backend service response is coming or not through the counter. And we have, like I said, we have mixed mode as well, like complete encrypted DOT plus DOT and mixed mode also. And I will tell you like how to differentiate between mixed mode and total encrypted mode from the counters. So we have disabled the cache for in the DNS default profile. Now let us see and try to generate the traffic. Okay. So this is a mixed mode, and if you see, this is a mixed mode where the front end is DOT and back end is DNS TCP in the VS2. So first we will try to do dig to normal DOT, like front end and back end DOT, and see the counters. So yeah, it will come 1 second. Yes, if you see here, DNS TCP TOT queries is the total TCP queries, and DNS TCP TOT server responses are the server response. I mean, it is the okay. So here, if you see, the total TCP TOT queries is the queries which we are sending to the backend server, and the server response are the responses which get from the backend server. So if you see, we have a new counter, DNS_DOT_toad queries and DNS_DOT_toad server responses. So these two are new counters. So why TCP and DOT both are increasing? Because DOT service is not service and vServer is nothing but a TCP type also. It is like the enhanced mode. I mean, it is a secure mode, but internally it is used as TCP also. So that's why we want to like increment the TCP counters as well. So this is a proxy. This is a DOT plus DOT mode. So that so here we see 4 of the counters. So we will also see like there is okay. So here let me play the video 1 second. Okay. So here another mode, if you see here, DNS TCP toad query has increased and DNS TCP toad server responses is increased, but DOT has 1 counter. So this is in this flow. What is happening is the front end is DOT and the back end is DNS TCP. So here, if you see DNS_DOT toad server response is not increasing because the backend is only TCP type. The server's response count is not increasing, whereas the front end is DOT type. That is why you can see the toad query for TCP and DOT both are increasing. So these are like differences where we can see that okay, how to use these counters and all these logs, how to verify like this is mixed mode or not, whether front end is like encrypted or back end is encrypted, and the DNS log as well. So you can use all these things to figure out how your traffic is going and all. So I will jump to packet capture. Let me know if you have any questions before that. Okay. So so this capture I have taken when with previously with this particular when I was doing that testing. So one thing to notice, like while doing this packet capture, you need to enable -cap SSL keys enable to capture the SSL keys, because we need the SSL keys to decrypt. What I mean is, if we go to the Wireshark, here you go to the preferences, then you go to protocol, go to the TLS part. Here, if you see here, we have the SSL keys. So we need to add the SSL keys here so that we can, let's say this is a particular standard query. If you see, so it is showing DNS because we have added the SSL keys. And here also in the below, right below, you'll see the frame and decrypted packet also. If you don't add SSL key, it will just show encrypted. Like what I mean is this TLS layer, it will show all encrypted. We will not able to see what is there. So when you add the SSL key, it will tell you the whatever the query is. It will decrypt it and it will tell you all the query, all the flags, DNS flags. Similarly, if you go to the response also, standard query response, here if you see, the TLS is again, it is encrypted, but if you below see the decrypted part, like it is like it has like disassembled the packet. So here if you see, the query is there. So if you open in the left hand side also, domain name system, here if you see the queries and the answer as well. In the answer, if you see, let us open this as well. So this is the name and this is the type, which is host address type, and the address. So basically we can see the packet capture with the SSL keys to debug more from the packet capture size, how which all flags are there for that particular query. There are SOA packets also, there are NS records also, many other things are there. So those things we can debug using the packet capture. But yeah, important thing to note is that we have to capture with the SSL keys from the NetScaler. So that's all from the demo side. Let me know anything else if you need. And we have a demo video in the we will share with you, which captures everything in detail, more detail. So yeah, back to you, Uttam.
Hey, thanks, Vivek. So I think we have covered most of part of it. If you need any help or anything related to DNS over TLS, you can post your questions on community channel, and I think Stephen will cover it.
Excellent. I think we've answered all of the queries which have been coming in all the way through here. If anyone has any queries that we haven't answered, please. I see one just appearing here. Do we have any estimates on the added traffic and latency overhead from DOT? Is that something we can share? Any estimates on added traffic?
Currently, we are doing the scale testing for that. I mean, we have tested with a few packets, and there are like some improvement. I mean, there will be little bit of drop in the latency and all part because of four-way handshake, but it is not much because we use like in unlike DNS over UDP or DNS over TLS where we close the connections. As it is over the TLS, we can keep the connection open and we reuse that particular SSL connection. No need to do the handshake again for each query. So that way, only the SSL part, like little bit overhead is there, but yeah, it is not very much. Scale testing result, we are working on it. We will share.
Okay, superb. Other question that's come in, how were you exporting the keys in the GUI? I'm guessing this was going into, I think it's settings, diagnostics, packet trace, isn't it? Off the top of my head, and there's a little tick box at the bottom. Is that what you were doing? How are you getting those keys?
Okay, so here, like from the CLI, what we can do is like start NS trace, then here -cap SSL. This you need to enable -size 0. So this is how we enable. So basically, you need to enable that, and while stopping, you need to do stop NS trace, and it will be there in your go to cell. Go to CD var NS trace ls -lrt. So this will be folder. If you go inside that, so here this particular key will be there. So NS trace SSL keys and the capture. So this SSL key you need for the packet capture. GUI, I think you are right. I mean, GUI page, like how the SSL keys we used to do, like any other SSL TCP type or SSL traffic, how we used to capture and generate. Same thing. It is nothing different.
Yeah, absolutely positive. I think it's system diagnostics, packet capture, perhaps. I'm not quite sure on the text, but it's the normal packet capturing process in the GUI. There's a tick box down at the bottom of the page to capture the keys. Got another question coming in here. DNS over HTTPS, is that going into the roadmap?
Yeah, we have it in our roadmap.
I think that's everything in the questions. So, unless anything more is going to pop in here, I think if we skip over to the next slide here, I think Isha is going to say a couple of words on the Citrix community portal.
Thanks, Stephen. Thank you so much, Vivek and Uttam, for a great demo. So guys, we have our Citrix community available where we will be having our recordings posted. So as you can see that we have our upcoming events as well as the previous events. Everything will be posted on the events section in the community, and you can not just take a look at the events that are upcoming or the previous ones. We have a lot more capabilities that you can try out. Starting from, you can go over the articles, increase your knowledge base. You can comment on the articles. If you have any queries, you can participate there. We have discussions where you can be bold enough to answer the queries, and also feel free to ask your questions as well. And we do have self-guided labs, which will be present in the education section on the top menu. So there you can click there and go to our self-sufficient 24/7 labs, and they are simple videos, simple use cases. Go and have a look at what our product has to offer. And then we have the events, which is available on the events section here. And so we will be introducing the tech zone section also. We have already added that, and that also will now be available on community. So we are collaborating and bringing in everything NetScaler and Citrix together in our Citrix community. So that's pretty much it. And for all the recordings, please visit the community section and click on the particular event you are interested in, and you can watch on demand directly from there. Yeah, that's pretty much it from my side. Over to you, Stephen.
Superb. Thank you very much. I think all that remains is to thank you all very much for presenting today, and to thank our audience for joining us. And we'll see you next time. Thank you. Goodbye.